Hello, can you hear me? Hello,
Good evening, sir.
yeah. We- What have you done since yesterday?
Sir, read the articles of chapter 12 and also solve the its first exercise.
You have sent some questions. What questions? Which ones are question doubts? You have sent some doubt, right, in chat.
Yes, sir. It's question 7 of exercise 21.
Discussed that yesterday, right?
Sir, in answer, they have not given the plus minus.
This is what is coming.
Yes, sir.
So cos 2 theta is 0 or cos theta is minus half. So from here you are getting 2 1 pi plus minus pi by 3, 2 pi by 3, right?
Yes, sir.
What are you getting from here? 2 1 pi plus minus pi by 2, right?
Yes, sir.
That's the answer.
Sir, in answer, in the back page, they have not mentioned the minus sign.
It's the same thing. This is basically what is the answer they have mentioned.
1 second.
2 theta is equal to this, so theta is coming out to be n pi plus minus pi by 4.
So so they have given in bracket n plus half into pi by 2.
Half into pi by 2. This is n pi by 2 plus n can be positive or negative. N can be any integer. So if you take some negative integers, what is coming? If we take integers here, we are getting 0 plus minus pi by 4. Then you're getting pi plus minus pi by 4. You're getting 2 pi plus minus pi by 4. These are the answers that we are getting. Here, what do you do? If you take 0, you get pi by 4. If you take minus 1, what will you get? Minus pi by 4. If you take n as 1, you will get 3 by 2, so 3 pi by 4. If you take n as minus 2, you'll get minus 3 by 2 minus 3 pi by 2. Those are the answers that we are also expecting.
Yes, sir.
It will come as the same answers, you just are writing in it a different way.
Yes, so that was the only doubt.
Okay, chapter 12. What have you read? What articles have you read?
Like you have already taught like sine rule. So they have given the sine rule and cosine rule, and they have modified the formula we already know the cosine rule by cos A, and they derive the formula of sine 2A.
Properties of triangles from the cosine rule, not sine 2. Where do you get sine 2? Sine 2 is not useful. You will get a by 2 and all.
Oh, yes, yes, sine A, right. Yes.
But you will need sine 2. Cos A is b square plus c square minus a square by 2bc. Using the identity cos A is equal to 1 minus 2 sine square a by 2 or 2 cos square a by 2 minus 1. We can find now formulas for sine a by 2 and cos a by 2.
Yes, sir.
We'll say 2 sine square a by 2 is 1 minus cos a. We'll use cosine rule here. 1 minus b square plus c square minus a square by 2bc, which becomes 2bc minus b square minus c square plus a square by 2bc, which is basically a square minus b minus c whole square by 2bc, right?
Yes, sir.
So that is going to be a plus b minus c and a minus b plus c by 2bc. And that is 2 sine square a by 2. So sine square a by 2 will come out as a plus b minus c, a plus c minus b by 4bc. And this top part can be written as 2s minus 2c and 2s minus 2b, right?
Yes, sir.
Because 2s is a plus b plus c. So 2s minus 2c is this, 2s minus 2b is this. So 2 gets cancelled and you get s minus c, s minus b by bc, right?
Yes, sir.
So we are getting from cosine rule, we are getting sine a by 2 is equal to root over s minus b, s minus c by bc. Exactly same process. Now you have to use this to get the formula for cos a by 2, right?
Yes, sir.
So you will end up with, you can see the derivation, it's the same derivation. We get formulas like this. We get cos a by 2 is equal to root over s minus a by bc. So therefore, tan a by 2 will be equal to root over s minus b, s minus c by s minus a, right?
Yes, sir.
So these three formulas will come, and now after this point, I don't think there is any new thing here in this section. So the first exercise should be pretty easy. There is just some calculations and all that is vast. Exercise
Yes,
26.
sir. Yes, sir.
So nothing major in exercise 26. This is what you need to use, and sine rule and cosine rule. The next section is, the first thing is projection rule, which is basically article 170. So the rule that A is equal to B cos C plus C cos B. And similarly, B will be C cos A plus A cos B, A cos C. Similarly, C will be A cos B plus B cos A. How am I writing these results? We will show the proof here. So pay attention. You need to understand what is happening. It's very easy actually.
Yes, sir.
The proof can be done by simply applying cosine rule everywhere, but that is not the proof that we want to understand. That's just algebra, right? But
Yes, sir.
what we want to do is, this is a triangle. This side is C, this side is B, this side is A. If I drop a perpendicular to D, it is obvious that this angle was B. So what is this length? This much is C cos B, right?
C cos B.
And similarly, in the other triangle ADC, this angle is C. So what
B
is
cos
this
C.
much? So B cos C. So it is obvious that C cos B plus B cos C is equal to A,
Yes, sir.
right? These two things are like projections of the component of this side on this side. Similarly, the component of this side on this. Correct?
Yes, sir.
Similarly, you can draw perpendicular to this side and similarly get this and this in terms of C cos A and A cos C, right?
Yes, sir.
All of these results are obvious from a geometrical point of view. I hope you are understanding.
Yes, sir. Understood.
Okay, so that is projection rule. The next rule is the tangent rule. Like, it's not super important. You don't need to remember it, but maybe sometimes it is useful in problems. The rule is asking us to prove something like this: tan of b minus c by 2 is equal to b minus c by b plus c cot a by 2. You don't need to actually remember it. So We are just going to prove this, the article 171 result, right? So actually the proof of it is pretty easy because this is a trigonometric ratio. This is a trigonometric ratio. I'll bring both the trigonometric things to one side, right? So
Yes, sir.
I will say it is tan b minus c by 2 divided by cot a by 2. So that will become a tan a by 2. And I have to show that b minus c by b plus c is equal to this, right?
Yes, sir.
And now I'll simplify this stuff using sine rule. Because b minus c by b plus c, by sine rule, b by sine b was equal to 2r, right? Is equal to c by sine c. So obviously b can be written as 2r sine b and c can be written as 2r sine c. Correct?
Yes, sir.
So it is very easy to see here that this side can be simply written as sine b minus sine c by sine b plus sine c.
Yes, sir.
And applying my sine c minus sine d formulas, you get 2 sine b minus c by 2 cos b plus c by 2 divided by 2 sine b plus c by 2 cos b minus c by 2, right?
Yes, sir.
This one and this one becomes tan b minus c by 2, and this one and this one becomes tan b plus c by 2. So you're getting tan b minus c by 2 by tan b plus c by 2, and b plus c by 2 is equal to tan of 90 minus a by 2. So that is simply a cot a by 2. So the denominator is a cot a by 2, so it will go in the numerator and become a tan a by 2.
Understood, sir.
So this article is not like something that you need to remember. You can easily prove it. So there's nothing to remember there. Then the next article is some examples are being shown, some proofs and some examples are shown. Then you have exercise 27. Exercise 27 is very important. You need to try questions in 27. There are quite a few questions, if you can see, 39 questions are there, right?
Yes,
Some
sir.
some of them will be hard, especially after 20. They might be hard questions, but you need to try as much as you can. The more you do, the better it will be for you. Okay.
Okay, sir.
So the work. I hope you are doing exercise 21.
Yes, sir.
Exercise 21 and exercise 27. The one that we are just seeing right now. These are super important exercises if you have to try to solve. So in Monday's class, we'll be doing problems on these, whatever doubts are there.
Okay.
Right now, we'll continue with the theory. The theory for this chapter is over, so we now have to go to chapter 15.
Solution of no.
Chapter 15, which is basically this chapter only continued. So it is properties of triangle part 2.
Yes.
So if you see the first article is again area of a triangle in different ways, right?
Yes, sir.
Article 198. That is obvious. There's nothing to discuss there, right?
Yes, sir.
You should know half BC sin A, half CA sin B, that stuff. Right?
Yes, sir.
Then Article 199 and 200 tells you about the construction of circumcircle, which we did in yesterday's class, and how
Yes, sir.
to prove that sine rule is correct, which we have already done. So Article 200 is just a proof of sine rule, right?
Yes, sir.
So we get A by sin A is equal to B by sin B is equal to C by sin C is equal to 2 capital R. And now we have already seen that area of a triangle was half BC sin A, right? It can be written in
Yes,
other
sir.
ways also, but this is one of the ways in which you can write area of the triangle. And sin A can be written as A by 2R. right?
Yes, sir.
So we can write half BC A by 2R, and this gives us a new formula for area, ABC by 4 capital R, right?
Yes, sir.
So this formula is connecting the circumradius to the area of the triangle and the sides. So you can, you have to remember this formula, it is quite important. So we can basically say that R is equal to ABC by 4 delta, or area is equal to ABC by 4R. These two versions. So this is a very important result. It will be useful later. Notice that he is writing capital S for area. We will not be writing capital S for radius, right?
Yes, sir.
We will always be using the delta form, because otherwise it might get confusing when you have small s and capital S and all, right?
Yes, sir.
Okay. The next part of this chapter is super important. The articles from here onwards, will be dealing with specific points of a triangle. So the first point is basically in center. So in center is basically the center of the in circle, right?
Yes, sir.
What is in circle?
Like when you construct the internal angle bisector.
Circle inside the triangle which touches all the three sides, right?
Yes, sir. Yes,
Touches
sir.
all the three sides, or basically the sides are tangent to the circle. And in order to find the circle, you have to make internal angle bisectors. Why do you have to make internal angle bisectors? Why internal angle bisectors are giving us the centers of this circle? Let's say this is bisecting. Why is this my in center? Do you know the reason?
Mm,
From here, apparently, you should be able to draw a circle which touches all the three sides, right?
yes, sir.
So why is it happening like that? That this is the center of the circle. The point of intersection of internal angle bisectors is the center of the in circle. Why is that?
Mm,
Have you heard about in circle before in lower classes?
yes, sir.
So did someone explain why you're doing like this?
No, sir.
Where did you hear it last time?
In class 7, I think.
9th 10th में कुछ नहीं पढ़े हो कभी इन सर्कल के बारे
नहीं, उसमें तो नहीं पढ़ाया गया।
में? Okay. The reason is, if you have an angle, let's say this is A, B, C. Let's make a bisector of this angle. This is half half. Both the angles are equal. But you can easily prove that any point on this bisector P is at the same perpendicular distance from both the sides. What I want to show is that PA and PD will be equal distances. How do I show that? I will do congruency of these two triangles.
Yes, sir.
How can we do congruency? First of all, notice that this angle and this angle are equal, and this angle is 90, this angle is 90. So anyway, the two triangles are similar triangles, right?
Yes, sir. And there is a common side also.
Similar triangles by AA and common side PB. If the common side is PB, then all the similarity ratio is 1. Right?
Yes,
So if similar triangles are there and similarity ratio is 1, then obviously all sides are equal and it is SSS. right?
Yes, sir.
Do you understand what I'm saying?
Yes, sir.
Because of similarity and one common side, you will get congruency. And because of congruency, now we know that PA is equal to PB. What is PA and PB? These are the perpendicular distances of the point P from the two lines that make up the angle, right?
Yes, sir.
So that is an important property, that any point lying on the angle bisector is at equal distance from the two sides that make the angle. Because of which, now you should realize that any point on this BI bisector is at equal distance from which two sides? You
Sir,
have to,
can you repeat the
you have to pay attention. If you get distracted, then it will be difficult. What did I say? What is my question? Any point lying on BI is equidistant from which two sides of the triangle?
like AB and BC?
And any point lying on AI is equidistant from which two sides?
AB and AC.
So what is the special about the common point I?
Hmm. Oh yes, they means they are equidistance from all, so they will be act as radius.
Common side I lies on both the bisectors, so it is at equal distance from all three sides.
Yes, sir.
If it is at equal distance from all three sides, clearly then it will be the center of the circle inside which touches all three sides.
Yes, sir.
Do you understand the reason right now why this is the in-center definition?
Yes, sir.
What we have to find now is basically radius of the in-circle. So I will draw my bisectors. This is my point I. I have to find radius of in-circle. So basically the length of the perpendicular from I to the side BC, which is going to be the same on all the sides. It has the same length, right?
Yes, sir.
If you take perpendicular from I to AB, that length is also same as this length. And again, this length, this perpendicular is also same length. This length is known as small r, which is in radius of the triangle. Correct?
Yes, sir.
Now, in order to find this in radius, we will do a construction. We will join I to C also. Anyway, this line was there. This is the angle bisector of C. So we are getting three different triangles: triangle AIB, triangle BIC, and triangle CIA. These three triangles, if you think about it, what is the area of BIC? Area.
Half into A
Half into A into perpendicular distance,
is
which
smaller.
is similarly area CIA will be half into B into smaller, and area AIB will be half into C into smaller, right?
Yes, sir.
So if you add the three triangles, you make the whole area of the big triangle del. Because AIC plus BIC plus AIB is the big triangle ABC. So area of the big triangle is equal to this. And this means that it is half into 2s into r. And because a plus b plus c is 2s, so this becomes rs. This is the first result, that del is equal to rs, so r is equal to del by s, right?
Yes, sir.
This is the first formula that we have seen. We will see several more formulas because there might be different ways in which the question could be asked for Inradius. This is, it is not always that you will be given semi-perimeter and area of the triangle. It's unlikely that they will give you that much information. Do you understand what I'm saying?
Yes, sir.
So remembering just the formula is not important. These are the things where you need to know how the formula came. How did the formula come here? We took the three triangles and looked at the area of the three triangles formed by the incenter and the vertices. And we added the areas of the triangles to get the full area of the big triangle. Right?
Yes, sir.
The second formula that we will see will use a very important property of circles. So A, B, C, and let's say my incenter is here somewhere. And I have drawn my circle. We know that the incircle is touching the three sides. This is my R. Let's label the point where it touches the sides. For example, this is D, this is F. You understand what D, E, F are?
Yes, sir. The point which are touching the triangles.
You should realize that D, E, F is not the same as the point where angle bisectors cut the opposite sides. This is not D or E or F. You should see this in the figure. The angle bisector will be cutting somewhere else, right?
Yes, sir.
The angle bisectors is used to find the incenter. After that, when you make the circle, it is not necessary that the circle tangent point will be same as where angle bisector was cutting. Do you understand what I'm saying?
Yes, sir.
So don't confuse yourself and think that this is the point where the angle bisector meets. Is it clear?
Yes, sir. Understood.
Okay, right now, let's say we have this situation. These are the points of tangency of the circle with the triangle sides. Now you have learnt in 10th grade at least that from an external point, two tangents can be drawn to a circle, right?
Yes, sir.
Have you seen figures like this sometimes in 10th grade circles? And
Yes, sir.
you should realize that if I take a point P and this is circle O, radius is same, this radius is also same, and radius is perpendicular to the tangent, right?
Yes, sir.
And since the common distance OP is like a hypotenuse, obviously this and this will be equal.
Yes, sir.
Because OQ and OT is radius, which is common, and hypotenuse is also common, OP. So obviously third side also has to be same. Which
Yes, sir.
means that from a point, if you draw two tangents to a circle from a point, the length of the tangent, this is known as the length of the tangent. The length of the segment from the point to the point of tangency where it touches. That length is called length of tangent, and that length of tangent is common if it is drawn from the same point. Correct?
Yes, sir.
So now you can see here that B is a point from where tangents are drawn to this incircle ray.
Yes, sir.
So length of tangent BD should be same as BE, right?
Yes, sir.
So let's call this as X. So this is also X. Similarly, A is a point from where tangents are drawn. So AE will be same as AF. Let's call that Y and Y. And similarly from C, tangents are CD and CF. Let's call it Z and Z. Right?
Yes, sir.
You should also know that our original symbols were A for BC, B for AC, and C for AB, the whole length. So we can see from here that x plus z is equal to A and x plus y is equal to C and y plus z is equal to B, right?
Yes, sir.
And also the addition of all of them, all the lengths 2x plus 2y plus 2z is equal to the perimeter of the triangle, right?
Yes, sir. 2s.
Which is 2s. So x plus y plus z is equal to s, right?
Yes, sir.
So that tells us that we are getting these results. So now we can say BD was simply x, right?
Yes, sir.
So if BD, you want to find out what is BD. BD is x, which is basically s minus b. How? Because s is this, and notice that b is this, right?
Yes, yes, sir. Understood.
CD is z. Z is what? S minus c, right?
Yes, sir.
And similarly, y is AE is y. Y is clearly S minus A, right?
Yes, sir.
So then there is a nice pattern. The length of the tangent from B is S minus B, small b, and S minus B. From here it was S minus small a and S minus small a. And from here it was S minus small c and S minus small c, right?
Yes, sir.
This pattern you should remember that from B, the length of tangent to the point of tangency is S minus B, S minus B, S minus A, S minus B.
Okay,
Correct?
sir. Yes, sir.
Now that we have this understanding, let's say this was the in center A, B, C. Let's say I have this is my in center I, and this is my half angle bisector. I know that this is a perpendicular and this is R. And I know this length was how much? S minus B,
S
right?
minus b.
And this angle is how much? It is B by 2
Yes, sir.
sin. Because it's an angle bisector that is connecting it to the in center, right?
Yes, sir.
So in the triangle BID, we can easily say tan of B by 2 is how much? R by S minus B.
Yes, sir.
So R is coming as S minus B tan B by 2, right?
Yes, sir.
Similarly, you can also prove that it is S minus C tan C by 2 and S minus A tan E by 2. The logic is same in all cases. You can draw like this from here C by 2 and this is S minus C by 2.
Yes, sir.
So first formula for R that we got is R is del by S. Second formula that we have gotten is R is S minus A tan E by 2 and so on. Right?
Yes, sir.
What was the logic behind this formula? How did we get the second formula?
Like same s minus c. I think from the figure I can say easily.
How to explain? We have just now discussed it. You should know what to say. How
Yes,
did
sir.
we get this formula?
Yes, sir. Like we go to that angle c by 2, and we already know that that corresponding side will be s minus c.
How do we know that already? Why? How did we get that?
By the tangent law.
Why are you on mute, right?
Yes, yes, sir.
You were on mute. Explain how we got it.
Like name the point like DC will be s minus c.
Why? Why is DC S minus C?
Like same logic, give the name BD is X.
चुप क्यों हो जा रहे हो बार बार? बोलना है ना रीजन पूरा.
Sir, so first we let name all the points where the circle is touching. So BD is X and BE will also X
Why is it also X?
because they are from the external point, and from the external point we have the same length of tangent.
Mm-hmm.
So BT will be X and BE will be X. Now give the name Y to AE and AE equal to AF, because of the same reason, like from the external point, when you draw the tangent, it will be of same length. And also name the CF equal to Z and CD equal to C will also be Z. And
Then
now
what?
we know that X plus Y plus Z equal to S.
Mm-hmm.
So we have we have Z equal to S minus Y plus Z, and is Z equal to X plus Y. So and X plus Y equal to C. So S minus C.
So then what?
So we got like X equal to S minus Y plus Z, and we already know that Y plus Z equal to C.
S minus C you have gotten. How will we get this formula now? R formula.
So again, draw the CI line.
Then
Yes,
what?
sir, CI. Then we have the angle bisector C by 2 angle. So we will apply tan C by 2, and tan C by 2 will be R by S minus C. So we will cross multiply it, and we have the R equal to S minus C into tan C by 2.
Okay. The third result will come when you write BD and CD. We have already gotten that tan B by 2 is equal to R by BD. Tan C by 2 is equal to R by CD. From here we can easily say that BD is R by tan B by 2 and CD is R by tan C by 2, right?
Yes, sir.
And then we can say that BD plus CD is equal to small a.
Yes, sir.
So if I now simplify, I will be able to show BD plus CD is small a. So R by tan B by 2 plus R by tan C by 2 is equal to small a. So R is equal to A by 1 by tan B by 2 plus 1 by tan C by 2. Do you understand what is happening?
Yes, sir.
This stuff we can simplify. 1 by tan means basically cos is on top, cos by sine, cos by sine. So sine will go on top. A sine B by 2, sine C by 2. And in the denominator, you're getting cos B by 2, sine C by 2 plus cos C by 2, sine B by 2. That is clearly becoming A sine B by 2 sine c by 2 divided by this is sine of b plus c by 2, which is 90 minus a by 2, so that is cos a by 2. Do you understand what we are doing?
Yes, sir.
The third formula is coming from this one only, the diagram that we made for this one. But now we are not writing it as s minus a, we are writing it as bd and cd.
Yes, sir.
And we are saying that bd plus cd is a. And from
Yes,
there, in terms of tan and r, we have simplified and we solved for r and we get this third formula.
yes, sir.
So we have 1, because r is del by s, 2, r is s minus b tan b by 2, 3, r is equal to a sine b by 2 sine c by 2 by cos a by 2. Obviously, here there are two more versions of this formula. Here also there are two more versions of this formula. Do you understand what I'm saying?
Yes, sir.
You can write it as s minus a tan a by 2 also. And we can write this as b sine c by 2 sine a by 2 by cos b by 2. Right?
Yes, sir.
Once we have these three results, from the third one we can get the last result, fourth and final result, because we can say that a by sine a is equal to 2 capital R. Therefore, a is equal to 2r sine a, and sine a can be written as half angles 4r sine a by 2 cos a by 2. So a by cos a by 2 is basically 4r sine a by 2. And there is a by cos a by 2 here. So I can write small r
Yes, sir.
as 4 capital R sine a by 2, sine b by 2, sine c by 2. From this only it is coming by sine rule.
Yes, sir. Understood.
This was coming from this figure, but instead of writing s minus b, we're writing bd/cd, right?
Yes, sir.
And this was coming by area of the triangle AIB, BIC and all. These are the
Understood.
4 results for Inradius, which are important to understand and know how it is coming. After this point in the chapter, you will see that there is the derivation for x radius also. X radius is radius of the x circle.
Yes, sir.
Basically, instead of internal angle bisectors, 2 of the angle bisectors could be external. One of them could be internal, right?
Yes, sir.
1 second.
Okay, sir.
Basically, if you make external angle bisectors of 2 of them, an internal angle bisector, then you will get a point here where the circle will be tangent to the external sides and one internal sides, right?
Yes, sir.
That is called an X circle. You have to read the sections where he talks about X circle. So article 205 till basically 1.5 pages, 205 till 207, he talks about all the X circles and derives the formulas for X circles. There are 3 X circles, A, B, C. The X circle opposite to this will be called I1. This is the center of that, and radius of this one will be R1. Opposite to B, it will be I2 and radius will be R2. And opposite to C, it will be I3 and radius will be R3. Right?
Yes, sir.
Article 205 to 207, he is deriving how to get the formulas for R1, R2, R3 and all. You need to read those derivations and see if you are understanding what is happening. Okay.
Okay, sir.
So the homework is exercise 21, exercise 27, and articles 205 to 207. In this is chapter 15, this is chapter 12, this is chapter 9. Okay.
Okay, sir.
We'll be discussing this stuff only mostly, and anything here if you didn't understand in the next class.
Okay, sir.
Make sure you come prepared after doing that.
So next class will be on Monday, na?
Yeah.
Okay, sir.
Okay. That's all for now then.
Thank you, sir.